Greetings and welcome, friends. Mr. Waddy here. We've been talking about writing equations in slope-intercept form, right? Linear equations. And today we're going to leave the realm of simple ordered pairs and graphs and M's and B's and enter the real world, the world of hydropower, apparently, and imagination, indeed. And we are going to be writing equations that model real-world situations. And it says this: a linear model is a linear function that models a real-life situation. When a quantity y changes at a constant rate, okay, so not everything in the real world changes at a constant rate. With respect to a quantity x, you can use the equation y equals mx plus b to model it. M is the constant rate of change, and b is the initial or starting value of y. So that's like our y-intercept, right? So that's what we think of in terms of these problems. And let's see if we can do this one problem here. So I'm going to try to help you out. So I'm going to be underlining things. I'm going to be figuring things out. Yeah. So let's read through this. It says, excluding hydropower, U.S. power plants used renewable energy sources to generate 105 million megawatt hours, okay, of electricity in 2007. By 2012, the amount of electricity generated had increased to 219 million megawatt hours. Write a linear model that represents the number of megawatt hours generated by non-hydropower, all of these words, my goodness, renewable energy sources as a function of the number of years since 2007. So guys, check this out. Function of the number of years since 2007 is going to be our input, and the number of megawatt hours generated will be our output. Okay? So in and out. All right, it says use the model to predict the number of megawatt hours that will be generated in 2017. So previously, we've used this VESA model where we're going to define our variables, and our variables are going to be those two things that we already described. So I'm going to let X represent the number of years since 2007. Yep. And the output Y, I agree, is going to be the number of megawatt hours. And even though we might not know what megawatt hours generated are, that's fine. We have data that we can work with and write an equation or a model that's going to help us solve this. Now, let's see. Another thing that I'm going to be doing is for Y, notice this says 219 million megawatt hours, right? And 105 million megawatt hours. Let's measure these in millions. All right. So instead of having to enter like super large numbers, here, you can put your phone away, thank you. We're going to just enter like 105 and 219, which are still larger numbers than we've been working with, but at least they're not like millions. So let's see if we can write an equation, all right, based off of these variables. And our equation, I'm expecting, is going to be of the form y equals mx plus b. All right? But notice what facts they told me. They said that they generated 105 million megawatt hours in 2007. Okay? So that is like a point that they've given me. 105 megawatt hours, my output, was generated in 2007. Now, I don't want to enter 2007 for X. Just a moment. I'm right back here now. So, ladies and gentlemen, instead of entering 2007, my x-coordinate, Ethan, notice, is years since 2007. So in the year 2007, how many years has it been since 2007? That's 0 years. When you're in the year 2007, 0 years have passed since 2007, right? Another point they gave us is 2012, they generated 219 million megawatt hours. So 219 is my output. And in 2012, how many years has it been since 2007? And how'd you get that, Amity? Oh, I wrote it wrong. Gentlemen, please be quiet. This is your last chance. Thank you. Right, so if I subtract them, we get 5. What was your other idea? You said add? Right, yeah, if you add 5 to 7, you get 12. So whichever way you imagine that, it is 5 years since 2007. So if I want to find the slope for this, I'm going to label this x1, y1, x2, and y2. So let's find the slope using our slope formula. All right, so far I've done the work of interpreting this into mathematical content instead of just like the real world situation. So m is equal to 219 minus 105 over 5 minus 0. So 219 minus 105, I happen to have written down here is 114. Over 5 minus 0, you guys know is 5. You guys are so quick. So here's my m. Now I also need to know my starting value. I need to know my starting value. Now, we're starting in the year 2007, right? And in the year 2007, I happen to know my starting value. So maybe I would have interpreted this right out of the problem that 105 is going to be my B. But even if not, notice that I know that this is B. How do I know that's B? How do I know? Why didn't I pick 219? Why am I picking 105? Right, that is the y-intercept because 0 is its x-coordinate. So using this information, my equation is y equals 114 fifths x plus 105. I know a value of y and x. I know this value of y and x, but I want my equation to represent all possible years and megawatt hours in millions. All right, so that's my equation. Nope. So let's see. Write a linear model. So if I wanted to know what the slope represented, because even though they didn't ask me to do that, but that is sometimes one of the things that they ask us to do. Notice that it's measuring, right, increasing million megawatt hours per year. This is in megawatt hours per year. MWHs over year, measured in millions of megawatt hours. So that means on average, they were making an extra 114 for every 5 years. All right, so that's what that means. And the 105, we already know what that represents. That was just in 2007. So guys, they then asked us to use the model to predict the number of megawatt hours that will be generated in 2017. So for 2017, how many years has it been since 2007? 2017 minus 2007 is 10. So what I'm going to do to predict this, I'm going to say let x equal 10. and I'm going to plug this into my model, and I'm going to see what y equals. Okay? So I could also use this to predict 2027 if I plugged in 20 for x. Right? I could plug in all sorts of numbers for x and use the model to make predictions, which is one of the values of having a model in the first place. So y equals 114 fifths times 10 plus 105. 10 divided by 5 is 2. 2 times 114. Here. So let's see. Let's add those numbers together. Cameron's got his calculator that he's using very properly. Plugging in numbers. I get 333 is y. So we don't have time for this side note. Thank you. Save it for Amity Math on YouTube. A is equal to, Ethan. The answer, right, is not just 333. It's saying we predict 333 million, Jimmy, megawatt hours, MWHs, in what year? In the year 2017. Okay, so this is my final answer. So what we did was we had a couple data points, we generated a model, and then we used that model to make a prediction. And many things in the world that we live in can be modeled mathematically. Not everything's going to be a linear model. Some things we'll find out are quadratic or sinusoidal or exponential. All sorts of weird models that mathematicians have generated. However, right, today we were looking at linear models. So thank you for watching, Internet friends. Adios.